Let's talk about the critical path method. In the previous part, we discussed the Gantt chart. The Gantt chart comes in handy when we have smaller projects, but it's not suitable for larger projects. For larger projects, we can use CPM, the critical path method, or PERT, the program evaluation and review technique. Both CPM and PERT are used to compute the completion time of a project. What's the difference between the two? The main difference is the way we measure the duration of each activity. In CPM, we use a single number to measure the duration of each activity. For example, activity lay foundation is done in 2 months. That means this activity is done exactly 2 months. On the other hand, in PERT, we are using 3 numbers to describe the duration of each activity, the longest possible duration, and the shortest possible duration, and the most likely duration. So, for example, the activity lay foundation will be done in 3 months in the worst scenario, and so this is the longest possible duration, 3 months. 1 month in the best scenario, so 1 month is the shortest possible duration, or 2 months most likely. 2 months is the most likely duration. In this part, we'll talk about the critical path, and our goal is to compute the duration of the entire project using the critical path method. Let's take an example. I want to show you how to use the critical path method. We want to build a house and we need to complete 3 activities. We have immediate predecessors and the duration of each activity. Question 1. Draw the activity on node network. So the activity on node network is a diagram for a project. We're going to use circles to represent an activity. And we'll use arrows to represent the precedence relationship. For example, here's A and here's B, and we can start B right after we are done with A. So we can draw an arrow like this from A to B. This means only after we finish A, we can start B. So let's draw this for the entire project. We're going to start from the start node, and the first activity is A, and the duration of this is 3. I'm going to put this right here, and I'm going to draw an arrow from start to A. After A, we can start B. So here's B. The duration is 2, and I'm going to draw an arrow from A to B. And also, after A, we can start C. And the duration of C is 1. I'm going to draw an arrow from A to C. Now, let's go to D. We can start D after B and C. So here's D. I'm going to draw an arrow from B to D and another arrow from C to D. And the duration of D is 3. Let's go to E. E follows B. So here's E. The duration of E is 1. And I'll draw an arrow from B to E. Next, F follows E. So F follows E. The duration of F is 1. Next, G follows D and F. G follows D and F, and the duration is 1. And this is the last activity. So we are done, and here's the finish node. I'm going to draw an arrow from G to finish. This is the activity on node network. Now let's go to question number 2. Find the completion time of the project. How long does it take to finish all of these? Should we add all the durations for all the activities? No. Let's look at D. D is waiting for B and C. And since B takes longer to finish, we can finish C while we are waiting for B. So we don't need to add the duration of C to the duration of the entire project. So you can notice that some of the activities can be done simultaneously. So think about all the durations that we should add to find the completion time of the project. So let's look at the sequence, this sequence, and this sequence. Since B takes longer to finish, C can be done while B is done. So we don't need to add C. Now let's look at this sequence and this sequence. Since D takes longer to finish than E and F together, we can finish E and F while we're finishing D. So that means we don't need to add E and F. So that means we can only add A and B and D and G to find the completion time of the project. So we can notice that this is a sequence of activities from start to finish, A, B, D, G. And are there any sequences of activities from start to finish? Yes, here's one, and here's another. So let's list them. And let's compute the duration of each sequence. So A, B, D, E, F, G, A, B, E, F, G takes 3 plus 2 plus 1 plus 1 plus 1, which is 9 months, 8 months. Next, A, B, D, G takes 3 plus 2 plus 3 plus 1, 9 months. And A, C, D, G, which is 3 plus 1 plus 3 plus 1, takes 8 months. So ABDG is the longest path. And we computed the length of ABDG to find the completion time of this project. Here's my question. Is the length of the longest path to start to finish always the duration of the entire project? And the answer is yes. Why? The reason why we took ABD was because ABD was longer than ACD. And we can finish ACD while we're doing ABD. And we also took ADG because this was longer than BDFG. And we can finish BDFG while we're doing BDG. So when we compute the duration of the entire project, we always need to take the longest path because we can finish the rest of the activities while we can finish the longest path. So we conclude that the project completion time is always the duration of the longest path to start to finish. And we call this longest path the critical path, and the activities on the critical path are called the critical activities. So the critical activities are those on the critical path, and the project's completion time is the sum of critical activities durations. A path in is a sequence of activities between a project's start and finish, and the critical path is the sequence of activities between a project's start time and finish time that takes the longest to complete. So here is how to find a project's completion time. List all the sequences of activities between start and finish. Compute the length of each sequence. Identify the longest path. This is the critical path. And the project completion time is the duration of the critical path. Let's go to question 3. Identify the critical path and critical activities. We already identified these activities, A, B, D, G. And let's take a moment to think about why we call them critical activities. We call them critical activities because if we delay one of them, the entire project is delayed. Their slack time is 0. So it's critical to finish them on time. So that's why we call them critical.